Hi, my name is Robin and you're welcome back to my channel. In this video, I'll be explaining types of roots of quadratic equations. And we shall be using this knowledge to solve more complex questions in quadratic equations. Let's dive right into it. Now, let's start. Remember our quadratic formula, which is gotten from ax squared plus bx plus c is equals to 0, where our quadratic formula is x is minus b plus or minus b squared minus 4ac all over 2a. Okay, now square root of b squared minus 4ac. Now here I'm interested in b squared minus 4ac to explain types of roots of quadratic equations. So here let d represent b squared minus 4ac. So if d represent that, so our quadratic formula will be minus b plus or minus square root of b squared minus 4ac is d now over 2a. Now, what is important to us is d. d is b squared, okay, b squared minus 4ac. Okay, d here is called discriminant. Discriminant of the equation. Okay, now let's start. C. So d, which is the discriminant, is equal to b squared minus 4ac. Let's start with the first one. The first one, when d is less than 0, when d is less than 0, the roots are complex and not real. So when d is less than 0, the roots are complex and not real. I'm going to show you this when we get to the graphical method of solving quadratic equation. So when d is less than 0, what does that mean? Okay, it means here that our b squared is less than our 4ac. That is what it means. It means b squared is less than 4ac. So for an example, we have 2x squared minus x plus 3 is equal to 0. Okay, what is our a? Our a here is 2. What is our b? Our b here is minus 1. And what is our c? Our c here is 3. You know how to get your a, b, and c. So now, let's get b squared, okay? What is our b squared? That is minus 1 squared, which is 1. I've gotten b squared. Let's get 4ac now. 4ac. That is 4 times, what is a? 2. What is c? 3. Okay? So this is what? This is 24. Here, you will see that our b squared is less than 4ac. Why? Our b squared is 1 and our 4ac is 24. You can see 1 is less than 24. So it simply means that if you solve this equation, the roots of the equation you are going to get is going to be complex and it's not, and it's going to be not real. When you talk about the roots of the equation, I'll quickly give an example. Remember, if you solve something like this now, for an example, okay, I'm just going to use factorization method. So x will be equal to 3 or 2. So this is the root. These are the root of the equation for this. So the solution you get in a quadratic equation are called roots of that equation. That is the meaning of that. So now I will quickly explain the second one. Okay? When d is greater than 0. When d is greater than 0, the roots are real and different. The roots are real and different. So for d to be greater than 0, it simply means our b squared must be greater than 4ac. Let's take an example of this. So an example is 2x squared minus 3x minus 1 is equal to 0. What is our a here? Our a is equals to 2, our b is equals to minus 3, and our c is equals to minus 1. So let's get b squared here. Our b squared, what is our b? Minus 3 squared. That is 9. Let's get 4ac. Okay? 4, what is our a? 2, what is our c? Minus 1. So this is minus 8. So in this case, b squared greater than 4ac. What is our b? 9. And what is our 4ac? Minus 8. 9 is greater than minus 8. It simply means that when you solve this equation here, you are going to get real roots and different. Real and different roots. That's what you are going to get. Don't worry, we are going to solve it so that you will see why this is complex, and you will see why this is real and different roots. Now let's take the last one. Now, the last one, d is equal to 0. When d is equal to 0, the roots are equal and real. So the roots are real and equal roots. So for that to happen, that means b squared must be equal to 4ac. Let's take an example of this. So 4x squared minus 12x plus 9 is equal to 0. So my a is 4, my b is minus 12, my c is 9. Okay? Let's see what b squared is going to give us. B squared. So that is minus 12 squared. That is 144. Let's see what 4ac is going to give us. 4 times, what is a? 4. What is c? 9. 4 times 4, 16. 16 times 9, 144. So b squared is equal to 4ac for that root to be real and equal. So what is b squared? 144. What is 4ac? 144. So if you solve this, the root of the equation is going to be equal and real root. Now, let's solve so that you can see why I said the first one is complex and not real, while the second one is real and different root, and the last one is equal and real root. Now, I want to show what kind of roots that we have. The first one says 2x squared minus x plus 3 is equals to 0. Okay? So, in this case, let's use our quadratic formula. B squared minus 4ac over 2a. Remember, I've shown you that this one is the first one, which is complex and not real roots. But I just want to show you why it is complex. Okay? So, our a is 2, our b is minus 1, and our c is 3. Okay? So, x is equals to minus, what is b? Minus 1 plus or minus. B is minus 1 minus, so 4 times what is a? 2, what is c? 3, all over 2a. That is, and our a is 2. So x is minus 1, minus times minus plus, that is 1 plus or minus. Minus 1 squared is 1 minus 4 times 2, 8 times 3, that is 24. All over 2 times 2 is 4. So this is x, 1 plus or minus. 1 minus 24, that is minus 23 over 4. And if you look at this, square root of minus 23 is going to, if you press your calculator, is going to give you error. You cannot find the square root of a negative number. So the only way you can solve this is using complex number. So that is why these roots are complex roots and not real. So that is why I told you here that d is going to be less than 0, which simply means b squared is less than 4ac. So when your b squared is less than 4ac, you are going to have a negative value in the root. So that is why we said this is not a real root and it is a complex root. Okay, so we know how to check now if a root is complex root for a particular quadratic equation. Now let's go to b. Now for b, 2x squared minus 3x minus 1 is equal to 0. Okay, our a is 2, our b is minus 3, and our c is minus 1. So let's use quadratic formula. So, which is b squared minus 4ac over 2a. So x minus, what is b? B is minus 3 plus or minus. B is minus 3, that is squared, minus 4 times a, that is 2, and what is c? Minus 1 all over 2a. What is a? 2. So here, minus times minus, that is plus. That is 3 plus or minus. 3 squared is 9 minus 4 times 2, 8 times minus 1, that is minus 8 over 4. So this is 3 plus or minus. Minus times minus, that is plus. So 9 plus 8, that is 17 divided by 4 here. So in this case, this is 3 plus or minus square root of 17. I can say square root of 17. That gives me 4.123. Okay? So divided by 4. So here I can say x is equal to 3 plus 4, 3 plus 4.123 over 4, or x is equal to 3 minus 4.123 over 4. Okay, so in this case I will say 3 plus 4.1, that is 7.123 over 4, or 3 minus that, so 3 minus 4.123, 4.123. Okay, so that will be minus 1.123 over 4. Now you can divide, but okay, let me quickly do it. Okay, so that is 7.123 divided by 4. So this will be 1.78, or 1.123 divided by 4. This will be minus 0.280. So now you can see that here the roots of this equation is, they are different roots and they are real because it is not complex. So that is why when d is greater than 0, which simply means b squared is greater than 4ac, you are going to have real and different roots. So the roots are different because this 1.78 is minus 0.280, and they are real because it is not complex number. Now let's go to the last question. Now taking the last question, C, 4x squared minus 12x plus 9 is equals to 0. Our A is 4, our B is minus 12, our C is 9. Now using x minus minus b plus or minus b squared minus 4ac over 2a. So x minus, what is b? That is minus 12 plus or minus. What is b minus 12? That is squared minus 4. What is a? 4. What is c? 9. 2. What is a? 4. So x is minus times minus, that is plus. That is 12 plus or minus. Minus 12 squared, that is 144 minus. Okay, so here what do we have? 4 times 4, that is 16. 16 times 9, that is 144 all over 8. So this is plus or minus. 144 minus 144, this is 0. So that is over 8. So this is x is equals to 12 plus square root of 0 is 0. Okay, so I can say here, so this is x is equals to 12 plus 0 over 8, or 12 minus 0 over 8, right? So x is equal to 12 plus 0, that is 12. That is 12 over 8, or 12 minus 0, that is 12. That is 12 over 8. You can still, divide things out. So 4 here is 3, 4 here is 2. 4 here is 3, 4 here is 2. Now you can see here that the roots are the same. So that is why when d is equal to 0, which simply means b squared is equals to 4ac, the roots will be equal and real roots. So you can see they are equal. 3 over 2, 3 over 2 are the same. They are equal. and they are real because it is not complex number. Now you are asked to solve this equation. Now remember, I've taught you how to use two methods now, factorization method and quadratic formula method. Some people love factorization method because it is faster to them, while some love quadratic formula because it is faster to them. But the purpose of this question is to show you when to use factorization method. Okay? And here, I'm really going to tell you, remember that our discriminant is b squared minus 4ac. Okay? So, when you are able to get the square root of your discriminant to be a perfect number, or when your discriminant is a perfect square, then you are required to use factorization method if the question does not tell you which method to use. So for an example, I will quickly show you something here. Okay, what is my A here? My A is 2. What is my B? My B is 3. And what is my C? Minus 5, right? So now, let's get D. D is B squared, that is 3 squared minus 4AC, 4 times, what is A? 2, what is C? Minus 5. So D is equal to, this is 9, 3 squared is 9. Minus times minus is plus. So 4 times 2, 8. 8 times 5, that is 40. D is equal to 49. 49 is a perfect square. Why? Because if I look for the square root of D, which is root of 49, I'm going to get 7. So 49 is a perfect square. So whenever the square root of your D is a number that is not decimal, that is what it means, then it means that you can factorize without no stress. Okay, so in this case, I can use factorization method for this. So this is how to know when to use factorization method. Now, for an example, let's say you are asked to solve for, let's say, 2x squared minus 3x minus 1 is equals to 0. Let's see if we can use factorization method for this. Here, my A is 2, my B is minus 3, and my C is minus 1. So let's get D. Remember, we always want to get D. If D is a perfect square, then we can use factorization method. If D is not a perfect square, then we cannot use factorization method. So D is B squared minus 4AC. So B squared, that is minus 3 squared minus 4AC. A is 2 and C is minus 1. So this is 9 plus 8. So D here is 17. Okay? 17 is not a perfect square. The reason why 17 is not a perfect square is that if you look for the square root of 17, it's not going to be whole number, it's going to be decimal. So the square root of 17 is 4.123. So this is not a whole number. So what this is telling us is that we cannot use a factorization method for this. We can only use a quadratic formula. So this is how to know when to use factorization method or when to use quadratic formula. Now here, there are cases where you might be given a question like, what must be added to the following to make it a perfect square? And these are all quadratic expressions. You can see not equal to 0. This is a quadratic expression, quadratic expression, quadratic expression. So they're asking what must be added to the following to make it a perfect square. Remember that I told you that third rule that I gave you, which says D is equal to 0, which simply means that B squared is equal to 4AC. This gives you equal roots, okay? Okay, so in this case, whenever you have a question that tells you what must be added to make the following a perfect square, or what must be added to this expression to make it a perfect square, okay? So all you need to know here is that, for an example, for the first one, a y squared plus 12y. Remember that a quadratic expression itself is ax squared plus bx plus c. This is a quadratic expression. So a quadratic expression has a, b, and c. So here, my a, I can compare ay squared plus by plus c. But you can see there's no constant here. So let's say k. So what must be added to make this a perfect square? Let's say is k plus k, for an example. Okay? So I'm saying k. Okay? So now, using this formula, because that is what gives us a perfect square, b squared is equal to 4ac. What is b? Our a here is, because y squared is y squared, our a is 1, because 1 is here, imaginary 1. Our y is our y. What is our b? Our b is 12. And what is our c? Our c is k. So we want to get the value of k, because we said k is what is required to make that expression a perfect square. So what is b? b is 12 squared. 4 times what is a? 1. What is c? K. 12 squared is 144. Is equal to 4 times 1, 4 times k, 4k. So I'm looking for k, I will divide by 4, right? Okay, this cancels this. So k is equal to 144 divided by 4. 144 divided by 4. That is 36. So what must be added to y squared plus 12y to make it a perfect square? And we said what must be added is k. And what is k? 36. So plus 36. So that is what needs to be added to this to make it a perfect square. Now the next question, it says what must be added to 2x squared minus 3x to make it a perfect square? Let's say k. Okay, so in this case we need to find the value of k. So we are using b squared is equal to 4ac. What is my a? My a is 2 here, my b is minus 3, and my c is k. So let's put all the values here. What is b? Minus 3 squared. 4 times what is a? 2. What is c? K. Minus 3 squared, that is 9, is equal to 4 times 2 times k, that is 8k. So we are looking for k, I will divide through by 8. So this cancels this. So here, my k is 9 over 8. So what must be added to 2x squared minus 3x to make it a perfect square? We said is k. And what is my k? 9 over 8. So that is what needs to be added to it to make it a perfect square. Now, you should pause the video to do C, so I can check if you are correct or wrong. Now, question C, let's see if you are correct. So what must be added to x squared minus 15x to make it a perfect square? Let's say it's k. So here, my a is 1, my b is minus 15, and my c is k. So we are using b squared is equals to 4ac. What is my b? That is minus 15. That is squared. 4 times what is a? 1. And what is c? K. Minus 15 squared is 225. So 225 is equal to 4k. I'm looking for k, so I will divide through by 4. Okay, so divide through by 4. This will cancel this. So my k is 225 over 4. So what must be added to x squared minus 15x to make it a perfect square? We said is plus k. So plus, what is k? 225 over 4. Easy. Wow, congratulations to you. You were able to stay to the end of this video. In my next video, I will be explaining the other methods that you can use to solve quadratic equation, which is the completing the square method. Hope to see you in my next video. Bye.